Hey guys, today we're going to look at this heat of reactions lab. So I've got just a couple things laid up over here and over there on the scale table. So I've got some 1 molar sodium hydroxide, I've got some 3 molar hydrochloric acid, which we're going to have to do a little bit of dilution on, especially if you read through the procedure and realize, oh wait, Mr. Hansen, you only need 0.5 molar or 1 molar. So that's why I have the graduated cylinder and plenty of distilled water here to do what we need to do. And then I've also got some sodium hydroxide pellets over there on the scale table that we're going to have to weigh out a little bit. So the very first one that we need to do is, experiment 1 is 4 grams of the pellet in 200 milliliters of water. So I am going to pour out 200 mils of distilled water into that first one, and then we'll let the temperature go to equilibrium. So there's 100 mils. And here is 200 mils of water in the cup. And now this probe, this is channel 1. So when we look at this, you'll see that there's 2 probes there. We need a second probe for experiment 3 where we have 100 mils and 100 mils of the 1 molar sodium hydroxide in the acid. But I am going to just stick that probe in there, and I'm going to let that get to an equilibrium while I go over there and weigh those 4 grams of pellets. So we are at almost there, probably 1 or 2 more pellets and we'll be there, depending on the size of pellet I put on. All right, I'm going to need to take one of the smaller ones away. And there we are. Okay, so we are at 3.3793 grams. 3.9793. Remember, the last one's a guess, so if you wrote down 93 or 94, it won't matter that much. Okay, let's take a look. We are at 24.1 degrees C on our temperature probe. And now we are ready to add. 24.1 is our initial temperature. I've added those pellets, and now I'm just going to stir it around. And I will tell you when all the pellets are dissolved. We still got quite a few pellets in the bottom of this cup. Our temperature is steadily rising here, where it looks like we're at 27.1. $28. We still have pellets. They are still dissolving inside of there. Okay. Well, while we're letting these pellets dissolve, because there's not a lot inside of there still, actually no, we're going to wait because we're almost there. We're almost there. Okay. And it looks like we're at almost 29 degrees right now. Still got a little bit of a pellet inside of there to dissolve. And nope, still a tiny speck in the bottom of that. Okay, everything has now dissolved inside of there, and we are at 28.7 degrees. So 28.7 degrees is our final temperature. For the next experiment, we need to have 200 mils of a 0.5 molar hydrochloric acid. Well, what that means is we need, with a 3 molar, how much? Okay, so I would urge you to get used to solutions and pause the video really quick to say how much of a 3 molar will I need to make 200 mils of a 0.5 molar. Okay, I gave you a small little pause point there before we go, and if your calculations are correct, and mine too, we need 33.3 milliliters of the 3 molar hydrochloric acid. I'm at 33, I just need a couple more drops. All right, pour a little bit back. $33 1/3. 33 1/3. Okay, so now all I have to do is fill this up to 100 and then add another 100, and we're ready to go for experiment 2. And I know what some of you are saying right now. Mr. Hansen, we learned always add acid, and you're absolutely right. If this was concentrated, I would not be making it that way. When I'm at a lower molarity, the risk for boiling or instantaneous boiling and harm to me is a little bit lower, but it's one risk that I'm willing to take, but I would not ask you guys to take. Because there is already water added to the acid solution. So I've taken away that massive heat transfer. That's the reason why we always have you add water to acid. Or sorry, acid to water, not the other way around. Okay, there's another 100. All right. I am going to pull the probe out of here and give it a quick little shuck and mix this around. And we're back to probe 1, first channel being inside of there. And I'm going to go weigh out the 4 grams of sodium hydroxide pellets while we're letting that temperature equalize. Okay. One more good-sized scoop should get us there. All right, I need to pull 1 pellet away, looks like. One more small pellet. I think that one's pretty small. Too bad I don't have like half pellets in here. That would be nice. So let's replace it with this one right here that I found that looks like it's a little bit smaller. And okay, we're just going to have to deal with the fact that we are a little bit over 4 grams, and we are at 4.0594. 4.0594. So really close to the 4 grams that we're shooting for. That will be close enough for what we're doing today. Okay? All right. So 24.7 degrees. That is what we are at. That is equalized. We are all good. We are at equilibrium. So now 24.6 starting temperature. Let's do another quick swirl. Make sure that it's not going to change anymore. All right. 24.6. Here we go. All right, we're going to do the same thing we did in the other one. I'm just going to swirl this around until we get all the pellets dissolved. And wow, we're already at 30 degrees. Last one hit, what, 28.7, 28.9 is the max. We almost hit 29. This one's already at 31.8. And we're still swirling it up. There's still a good chunk of pellets inside of there too. So they're dissolving, but there's still a good amount in there. We're at 34.8, we're almost at 35. Still dissolving. Still dissolving. Yep, I still got some pellets inside the bottom of this cup. They're for the most part dissolved, so we're probably not going to see any more huge temperature jumps, but there's still little tiny pellets at the bottom, so we might see some minor temperature jumps still, like a half a degree or something. Looks like 36.3 is how hot we got, and I don't think, yep, 36.3 seems to be where we're at. There's no more pellets in the bottom. 36.3, that was the highest temperature it got to. It's already starting to come down, so we don't want to miss our end data point for high temperature because it's starting to come down to room equilibrium. So 36 point, what did we say? 36.3, 36.5, somewhere in there. That's our final temperature for when you're doing temperature change. All right, for the last one, I'm going to need 2 cups, but I'm going to do the experiment inside of this one here. So I need 100 mils of the 1 molar base and then 100 mils of 1 molar hydrochloric. So while I'm pouring this one, you could do some quick math to tell me how many milliliters of the hydrochloric, 3 molar hydrochloric, do I need to make 100 milliliters of a 1 molar hydrochloric. All right, we are at 100 here. We're at 100. So I'm going to put that inside of this cup. Okay. And now, if you said 33.3 again, you are absolutely correct. See, even though we are making less of it, we're making it slightly more concentrated. So we're making half the amount, twice the concentration. So the math should play out exactly the same, and it does. 1, 2. Need just a little bit more in here. 33.3. Okay. And now I'm going to finish this up. To 100. Excellent. Put it inside of here to swirl it up. And now I'm going to use that second channel. So channel 2 is in the 1 molar hydrochloric acid. I'm going to swirl it up. Okay. And now channel 1, I'm going to shuck the liquid off of this one. Channel 1 is inside the 1 molar sodium hydroxide base. Okay. So we're going to let those two temperatures kind of equalize just a little bit before we go. And it looks like both of them are reading, 24.8 and 25.0. So it looks like both of them are reading an average of 24.9. So I am going to pull both thermometers out. Actually, I'll leave this one in. Okay, so this is channel 2. Channel 2, 24.9. Hey, look, it's reading 24.9, which is the average temperature between the two. We'll take that as our initial. And here we go. Adding the base, swirling it up. And keep an eye on that temperature. We stop when it hits a maximum. So it's at 31.1 right now, 31.2, 31.3. And that appears to be where it's going to stop, at 31.3. Okay, ladies and gents, what I want you to do with this is we have that equation, Q equals MC delta T. I want you to tell me what's interesting about this. When you calculate the energies, the Q for all of these, what's interesting about it? And remember that the Q is going to be calculated for what the main thing is. And the main thing is water in this case, or the solution, or what's happening with this solution of water. So when we look at the temperature change, it's of the solution. When we look at the mass, we're going to use water's density of 1 gram per milliliter to figure out the mass of water or the mass of the solution that I use. And then we're going to use, water-specific heat as well, because the majority of what this is water. And we kept everything else kind of constant here. So it won't be until you get to some of the later questions inside the lab handout where you will actually incorporate the mass of the sodium hydroxide or the molarity of the acid. So come to class on Monday with something interesting to tell me about experiment 1, 2, and 3 and how they all relate. See you guys in class.